Okay, Assalamualaikum and selamat sejahtera. My name is Muhammad Fakhrul SYAZWAN. Okay, for this video, I will explain for my simulation. Okay, this is the JMAC designer that I use for this project to design excitation coil. Okay, this is the excitation coil that I have designed. This is the design A using 25 kilohertz. The reason why I use 25 kilohertz because 25 kilohertz is a range for excite nanoparticle in magnetic particle imaging. Okay, in design A, this is for without ferrite. And this, as you can see on the left side, this is the ferrite material that I use. So for this project I use manganese zinc ferrite 1200 for the core, and the coil I use copper. Okay, this is design without ferrite. For the contour plot, as you can see, this is the contour plot produced from design A without ferrite. Okay, this is the contour plot with vector plot, magnetic flux density. Okay, if you can see, this is on the bottom, it shows the maximum and minimum value. Okay, this is the maximum value for contour plot, 7.991 micro Tesla. This is from the phase 0. On the phase 0, for vector plot, it shows maximum and minimum value 0, because on the one cycle of waveform, when it's on the 0, the maximum and minimum value remain 0. So when I change to 90 degree or phase, okay, the value for vector plot, the maximum value shows 1.1312 times 10 to the power of 5. This is the maximum value of magnetic flux density for vector plot. As you can see, the vector plots becomes red, and it enter the excitation coil from the top and flow through the bottom, and the minimum value is 0. Okay, for magnetic flux density contour plot, the maximum and minimum value remain the same. On the center of the excitation coil, on the maximum value, it shows this is the maximum value. Okay, for 180 degree or 100 phase 180, okay, as you can see, the maximum and minimum value for vector plots becomes 0, because on the one cycle of waveform, when the waveform move from 90 to 180, it's on the x-axis, so means there is no value on that time, so this shows 0. So when I change to 270 degree or phase 270, the maximum value shows for vector plot 1.1312 times 10 to the power of 5, and the vector plot came from bottom and enter from bottom to the top, because on one cycle of waveform, 270 is on the negative side, so that's why the vector plot came from the bottom, enter through the excitation coil to the top. Okay, when I change to 360 degree or phase 360. Okay, the vector plot, the maximum value for vector plot becomes 0. Also with the minimum becomes 0, because on the one cycle of waveform, 360 on the x-axis, so that's mean the one cycle of waveform have complete, and that's why the maximum minimum value for vector plot shows 0. For contour plot, the maximum and minimum value remain the same from the beginning, because the maximum value are at the center of the excitation coil. Okay, so this is without ferrite. I will show with ferrite. Okay, this is the design A with ferrite. Okay, the surrounding area is the air region, for mesh region for this design. Okay, as you can see, the maximum value for magnetic flux density contour plot using ferrite as a core is 1.1473 times the power of 4, means it's 114.73 micro Tesla, and the minimum value is 5.2825 times 10 to the power of 10. This is the using ferrite for magnetic plot, magnetic flux density for vector plot. The maximum value is 2.0097 times 10 to the power of 14. As you can see, the vector plot, when it's entering the excitation coil, it's become more darkened for the arrow, but when the arrow or vector plot came up from the excitation coil, it become brighter or yellowish. So this is the maximum value for contour plot. It shows here at the center of the core. So when I change to 90 for degree of phase, the vector plot, maximum value of vector plot shows here. The maximum value is 1.6225 times 10 to the power of 4, and the minimum value is 7.4705 times 10 to the power of 10. So the vector plot entering the excitation coil from the top through the bottom with the maximum value. For the contour plot, it's remain the same. Maximum value 1.1473 times 10 to the power of 4, and the minimum value is 5.2825 times 10 to the power of 10. Okay, when I change to 180, the vector plot, the value for maximum vector plot is same with the on the zero phase, but for this one, the vector plot enter the excitation coil from the top through the bottom. As you can see, when the vector plot entering the excitation coil, the color of the arrow or vector changing to darken, but when it flow through the excitation coil, the vector color become yellowish, it become brighter. Okay, when I change to 270 degree or phase 270, the maximum value and minimum value of vector plot shows here 1.6225 times 10 to the power of 4 for the maximum value, and the minimum value 7.4705 times 10 to the power of 10. So the vector plot entering the excitation coil from the bottom to the top, because on the phase 270, the one cycle of waveform, 270, the wave is on the negative side of the waveform, so that's why the vector plot entering the excitation coil from the bottom and to the top. Okay, when I change to 360 for phase, the vector plot shows same with when the phase is 0 and 180, because one cycle of waveform is complete and 360 on the x-axis. The vector plot entering the excitation coil from the bottom through the top, when it enter the excitation coil, the vector color become more darkened and it flow through the core and go up from the top and become more brighter or yellowish. Good. Okay, this is design A from the using core as a ferrite. So I will show the design B for my project. Okay, this is design B for my project. Okay. Okay, this is design B using 25 kHz, same with design A. Design B is similar design with design A, but design B is have been divided into smaller subcoils. So I have divided smaller subcoil into 5 smaller subcoil. Okay, this is design B without ferrite. It means the core is a region, so the excitation coil is still using the same material, which is copper. Okay, for this design B, on the phase 0, the maximum value and minimum value of vector plot is 0, because on the one cycle of waveform, on 0 on the x-axis, the waveform starting from the 0, and the maximum value of the magnetic flux density of contour plot shows here. Maximum value is on the center, 8.0417 times 10 to the power of 6, means that 8.0417 micro Tesla, and the minimum value is 2.1090 times 10 to the power of 10. Okay, this is on the phase 0. When I change to 90, the vector plot shows entering the excitation coil through the from the top to the bottom, and the maximum value of the vector plot shows here 1.1373 times 10 to the power of 5. It means that it's 113.73 micro Tesla. That is the maximum value of the vector plot. As you can see, the vector plots become blue in color, the arrow, and the minimum value is 2.9826 times 10 to the power of 10. So for contour plot, magnetic flux density contour plot, the maximum value and the minimum value remains the same. On the phase 90, on the one cycle of waveform, the vector plot on the positive side, so that's why the vector plot entering the excitation coil from the top. So when I change to 180 degree or phase 180, the vector plot entering the excitation coil from the top, but the value of the vector plot and the maximum value is 0. So it means for the one cycle of waveform, it's half of the one cycle of waveform. When I change to 270, the vector plot came from the bottom through the excitation coil and to the top. So as you can see here, before entering the excitation coil, the color of vector plot of the arrow more blue in color, but when start entering the excitation coil, the arrow become more yellow, and at the center it become more red in color, and when the vector want to exit from the excitation coil, the vector color become from yellowish to the blue color, to the minimum value of the vector plot. Okay, when I change to 360 degree or phase 360, the maximum value and minimum value for magnetic flux density of vector plot becomes 0, because on the phase 360, the one cycle of waveform have complete, and 360 on the x-axis. So that's why the maximum minimum value is 0, and the magnetic flux density for contour plots, maximum value and minimum value remains the same from the beginning. Okay, then I will show for the design B with ferrite. Okay, this is design B with ferrite as a core. Okay, when on the phase 0, the maximum value of the vector plot is 5.0243 times 10 to the power of 15, and the vector plot entering the excitation coil from the bottom to the top with the maximum value. And for magnetic flux density of contour plot, the maximum value is 1.1325 times 10 to the power of 4. It means that the maximum value is 113.25 micro Tesla, and the minimum value is 2.3834 times 10 to the power of 10. The maximum value on the center of the core using ferrite. So when I change to I change to 90 degree or phase 90, the maximum value entering the excitation coil is 1.6017 times 10 to the power of negative 4. It start entering from the top to the bottom, and the minimum value is 3.3703 times 10 to the power of 3. The maximum value of the counter plot shows the same from the beginning. On the one cycle of waveform, on the phase 90, the waveform start on the top of the axis, so that's why the vector plot are entering the excitation coil from the top. As you can see, when it start entering the excitation coil through the center, the vector line become more red and become more on the maximum value, and when it exit from the excitation coil, it become blue on the minimum value. When I change to 180 degree or phase 180, the maximum value on the of the vector plot is 5.0243 times 10 to the power of 15. It's on the max value, and the minimum value is 0. Means as there is no minimum value for this phase 180 degree. When I change to 270, the vector plot entering the excitation coil from the bottom of the excitation coil and exit on the top, because on the phase 270, on the one cycle of waveform, 270 is on the negative side of the waveform, so that's why the vector entering the excitation coil from the bottom, and when it's on the vector plot or the arrow entering the excitation coil, the maximum value of the vector plot shows, and when shows here 1.6017 times 10 to the power of 4, and in the minimum value or the surrounding outside of the excitation coil is 3.3707 times 10 to the power of 10. Okay, when I change to 360, the maximum value of vector plot is 5.043 times 10 to the power of 15, and the minimum value is 0. It's mean on the surrounding area, there is no minimum value of the vector plot. For the counter plot, the maximum and minimum value remain the same from the beginning. 1.1325 times 10 to the power of 4 means it's 113.25 microtesla, and the minimum value is 2.3834 times 10 to the power of 10. Okay, so that is for the simulation. For the project, I want to see the difference between the counter plot, the magnetic flux density of counter plot for the design A and design B. Design A with ferrite, design A without ferrite shows the difference value of counter plot. Also with design A with ferrite, design B without ferrite also shows the different value of counter plot, and with design B with ferrite, the maximum value of the counter plot. So that's all from me. you.